This is the story of a commitment. It was first made over 100 years ago when the people of Western Electric began to make the things needed by the Bell telephone companies to build the communications network. Today, 1 of every 5 Bell system people works at Western. What you'll see is a chapter out of their continuing commitment to quality, reliability, and service in the work they do and how they do it.
Hi, Don. We just received the telephone company outline specification on this new ESS office that we're going to put in for you. What I was going to suggest to you...
And that's the way it usually begins. A series of phone calls, a lot of meetings, and we've got another multi-million-dollar order on the board. This Columbia City project's a little different. It's not an urban renewal job or a shopping center we're talking about. It's a whole new town. The way it works is the telephone company needs to provide communication service for a new area. So they come to us at one of Western Electric's regional centers, where together we do the basic planning and engineering. We'll then take it over from there, order the equipment, and see that it gets installed on schedule. Once we take that phone company order, we've done a lot more than agree to a contract. We've made a solid commitment.
When the basic requirements come in from the phone company, they tell us just what's going into the new Columbia Central Office. So many terminal lines, such and such equipment, to serve so many customers. These are the specifications we'll work with. What we do with them is what Western's all about.
One thing that the telephone company is very concerned about here, fellows, is the ability for the growth of this office because of the changes that might take place. Now, do you feel that we have enough growth?
This whole department is made up of specification detailers. We lay out all the details for the work that starts at ground level. Now, sometimes it's in addition to an older installation. This Columbia one is starting from scratch. A brand new central office. It's the most modern one we make. An all-electronic switching system we call ESS.
There'll be miles of cable coming into Columbia's new central office. It'll come first in thick strands and split off into smaller units in the bays. We measure and route the cables and make sure the installers know what cables go into which channels.
We're dealing in flow weights and structures here, not electronics. You take the other people back there. They're doing circuits, piecing one to work with another. Now, compatibility is their problem. Our problem is to find space for it.
Fred, how about you? How about the racking?
The racking's going to be okay, Dick.
By the time we get through working out the specs on the Columbia job, we'll have a whole set of drawings of our power, cable, transmission, and switching equipment. And when these are all tied together, we've got our master blueprint.
This is one of our regional data centers. Now, what we do is translate the plans into a special product code and feed it to that computer back there. When the data gets to our manufacturing locations, they'll break it down to simple component parts. Wires, circuits, relays, that kind of thing. The beauty of it is, most of the equipment is standard stuff you can order throughout Western. And we don't worry about the exact makeup of each component. We just put down the code. They'll know what to make.
Terry, Rich Schreiber. Hey, my friend, I've got a problem here on some covers. Need some covers for 280 type relays.
Make it or buy it. We're always coming up against that in our purchasing operation. What we don't need to make, we buy from more than 50,000 outside suppliers, many of them small businesses. What we don't buy, we make in Western plants all over the country.
The Columbia specs call for a lot of telephone cable. And here's where you start, with copper rod. The rod comes in here at 5/16 inch thick, but by the time we get through with it, we'll have it trimmed down to a lot smaller gauges. We call it wire drawing. passing it through a series of carbide or diamond dies, running at 7,500 feet a minute, reducing it till we get just the sizes we want.
Most people could care less what's in the box of phone equipment they use, just as long as it works and doesn't cost too much. On the other hand, they might just be surprised if they could see the amount of equipment it takes to tie that phone hanging on the kitchen wall to the rest of the world. The Columbia Central Office is electronic switching. And if there's one thing that made electronic switching possible, it was the invention of the transistor by our own Bell Labs. Did you know it was right here at Western where the first transistors came off the manufacturing line?
These miniature electronic devices have put a lot of gray hair on engineering heads. They're tiny, they're fragile, and they contaminate easily. So you have to design complex machinery to handle them. Machines that can't use stuff like grease for moving parts. Where you work inside vacuum chambers controlled to 5 parts per million moisture, 100 parts per million oxygen.
Now here's an area where we go to extremes. This clean room was specially set up to make ceramic substrates for integrated memory circuits, which we use by the millions in our latest switching and transmission systems. Our biggest headache is contamination. Dust, particles, moisture. One speck of foreign matter across a circuit junction wipes it out completely. If nobody ever came in here, we could keep it 100% clean. As soon as you introduce people, the dust count goes wild.
At first, some of the girls complained about these outfits because it crushed their hairdos, you know. And you can't wear makeup either. But heck, my husband knows what I look like when I get up in the morning.
I've been doing this work for over 6 years now and watched it getting more and more sophisticated. Like these tiny chips. There are whole networks of transistors, diodes, and capacitors. Too small to see without a microscope. They're the brain of the memory core we're building, which decodes the information coming into ESS. My job is bonding the chips to the substrates that come to us from the clean rooms. Afterwards, we test each chip electrically.
For a manufacturing engineer, life is full of decisions, like which way to go. Sometimes the big machine is the only way we know. Sometimes the best way is the simplest. A machine can't compete with a sensitive hand, the way the eye sees relationships and movement, the way a mind can judge and control. People are more flexible and smarter. Take this operation, for example. We call it large lot processing.
These tiny diodes are used by the thousands in an ESS job like the Columbia office. Now, we know we could design and build a machine to make these parts, but we've done something better. With a few ingenious tools, we've multiplied our output with a production rate a machine could hardly match. And this is a team effort. We switch jobs around regularly here. You know a machine that can load 2,000 diodes at one time?
This pulp insulator is no push-button operation. We've got 60 wires running in here at high speed, getting a coat of wood pulp before they wind up on those reels. Sounds easy? Well, it takes a lot of teamwork and hustling during reel changes when the spools fill up. You can't afford to mess around because that insulator is going to keep on running. putting out over 2 million feet of wire every 24 hours.
Probably the last thing you'd expect to find smack in the middle of a cable plant is a little red schoolhouse.
Myself, when I was first learning it, that it might seem a little simple in the classroom, and when you get out there, things like just a drain clogging up in the pumper wasn't very obvious.
This training program's pretty unique. We had to get one going when telephone company orders for cable kept building up. In fact, our forecasts told us we had to open new plants, and that meant training more people for today's needs, and still more for tomorrow's.
I always wanted to work for a big company, which is why I came to Western in the first place, figuring there'd be better opportunity. So when I was offered the chance to go to the company college in Princeton, you can bet I accepted that offer.
I want to work on the problem, but I don't want to be a participant. Therefore, I want to support you in the things that you want to do. Well, let me see how well you make out with this one here.
With new communities like Columbia springing up all around the country, Western's got to grow along with them. And that means more people building equipment for the network, and more people to manage the business. One of the courses I had was how to communicate with other people. Sounds like just common sense? Well, when you're out there in the factory working with people day after day, you need all the experience you can get.
In this business, you can't just stick with the existing technology. The whole field's changing too fast. That's how Western's Engineering Research Center came about. It started as an experiment, but in a few years, the idea began to really pay off. Telephone offices like Columbia's wouldn't be possible without a research center and the Bell Laboratories. Bell Labs designs it, we adapt it to manufacture. Then, together with our plant people, we look for ways to make it better and less costly. Whatever we develop here, we have to get our factory people believing in it and doing it.
We've made some big changes here on the manufacturing line, working with our people at the research center. Like the time we got interested in using lasers for a delicate cutting operation on our ESS circuit boards. We went to our research people for a feasibility study. They came back with proof it would work, and together we pioneered the first lasers on the production line.
Aside from government work, Western Electric's got just one customer. That's the Bell system. But the telephone companies don't have to buy from us. We've got plenty of competition from other sources. So if our customer wants his equipment by a certain date, and we can't make it or we can't meet a competitive price, maybe somebody else can.
Western's built this ultra-modern plant just to make PBXs, private exchange service equipment, to consolidate manufacturing spread across the country and improve delivery of PBXs to the phone companies. Some of them will wind up in businesses and hotels in the Columbia area. In fact, we make a whole range of new products for the business community: teletype apparatus, data sets, and PBX equipment.
We've put everything under one roof here. You don't see any traditional assembly lines. It's all open, free flow. Sure, it's a big investment, but we're not just selling hardware. We're selling an integrated system and backing it with our experience. And that means we're responsible for the product we turn out just as long as our customers using it.
I can remember the time when all the phones we made here were black. And that'll give you some idea how long I've been at Western. Counting colors, we now turn out over 1,500 different types of instruments for the Bell system. It adds up to over 10 million phones a year. Maybe 40,000 of them will wind up in that Columbia City area.
We've had to solve a lot of hairy problems trying to pack all these components into such a small package. And we're still putting more in, refining the circuits, making the instrument more compact to make room for services to come in the future.
Western's built its reputation on quality control, and our specialty here is wearing things out. It's a test of endurance against time. If a part fails, we look for ways of improving it. Sometimes an engineer will come up with a cost reduction idea and brings it to us to test, to see if it's better than the one we're using now. Based on what we find, he'll either go ahead or make a change in his design. Sometimes you can't improve on a good design. We haven't been able to wear out these dials yet.
This 600 pair cable is going to spend the rest of its life buried in 4 feet of ground under Columbia City. Now, it'll need plenty of insulation, so we seal it in paper, steel, and aluminum, and then we give it a coat of polyethylene. Not even a groundhog can eat through all that.
Talk about commitments. We have to keep an inventory of some 12,000 manufactured and supply items in our warehouses. When orders come in from the phone companies, get them through here and on their way to the customers within 24 hours. The orders on the Columbia job are sizable, all right, but they're just a small part of the overall action here.
Besides manufacturing new equipment, we have a large number of service centers where we get back a lot of used equipment from the field. And what we do is give it a complete checkout, recondition it, and send it out as good as new.
Nobody thinks about it much, but every time you pick up a phone and dial a number, it takes a fantastic amount of backup equipment to connect it to every other number in the Bell system network and to all the other phones around the world.
About 200 of these ESS switching frames are tagged for the Columbia office. Now, by themselves, they mean nothing. But tie them together with the transmission equipment we make, the microwave systems, the coaxial cable systems, and the people of Columbia will be able to communicate with any place on Earth.
What we're doing is simulating the conditions the phone company people will face when this ESS system is set up in the Columbia office. We put all the individual networks together. First we test them one by one, and then as a complete system. If we catch any bugs, we'll dig them out.
installers are a special kind of breed. You get to feel this way because, well, you're always on the go, working as a team, troubleshooting an older installation, or maybe putting in a big new one like this Columbia job. And here's where it all comes together. The wire and cable, the switching and transmitting equipment. Now, we got a couple hundred frames going into these bays, so I guess we'll be settling down for a while.
1101. Is there an orange?
1101.
There should be an orange, one white, and an orange, two white.
Columbia City is tied into the Bell System network, but this story has no end. It's just part of the daily commitment of Western people doing an essential part of the Bell System job. The same people who helped build the best communications system in the world today.